cumulative incidence and risk, incidence rate and density, and then the odds. So that is what we are going to discuss. So what are the measures used in epidemiology? We have several measures used in epidemiology. And the first measure, as we talked about in our definition, is frequency. We have already seen association when it comes to analytical studies, and we also have impact. So you'll find some studies a person has written impact. Yeah. So in the disease frequency, the purpose is description, surveillance, and risk assessment. So for you to be able to talk about description, surveillance, risk assessment, then you are talking about incidence and prevalence. We are going to see that. This is just a summary. And then in association, when now you want to associate a causation and an outcome, the purpose is basically for etiology. Etiology is what you have always done in your basic sciences and also prognosis. So here for you to get the etiology and prognosis, we are talking about the relative risk, the rate ratio, and the odds ratio. And then when you are doing an impact, those studies that we talked about, impact, about what the purpose is for etiology, for health appraisal, for policy formulation. And example of those measures that you can include attributable risk percent, and population attributable risk. So this impact at this level, we shall just mention, we shall not go into details about it, but we shall also talk maybe at length about incidence, prevalence, and also measures of association. So the measures of frequency, it's the basic tool to describe quantitatively the cause and patterns of disease. Quantitative in the sense that you are giving some numerical, or you are attaching some numerical value. For example, you can be able to say the number of people in a particular population with epilepsy is 10. So quantitatively, you have quantified it, or any other event related to health in human population. So for instance, how many people are affected with certain diseases? What is the rate at which the disease is occurring? And how does the disease burden vary by geographical region? Basically, when you look at this, you are giving numerical values. I've forgotten to, yeah, okay, it is recording, good. And then, so epidemiology, in a nutshell, we usually deal with numbers where we count, we divide, and then we compare. So when we are counting, we are establishing the number, that is frequency. When you are dividing, we are doing those calculations of for comparative purposes, and then when we compare is where now we analyze. Sorry. So for example, to measure an event, for instance, the number of new HIV or AIDS cases. So in city A, we can say we have 58. In city B, we have 35. That one is, we are doing what? We are counting. And then we can still count and then divide. That is measuring an event still. Where you take in city A, you have 58 cases in 1990, and then in city B, we have 35 cases between 1989 to 1990. And the total population there was, in city A, was 25,000, and city B was 7,000. So we can be able to divide how many, the number of cases in each of the city per year. So for example, in city A, you can take the number of cases divided by the population at risk per 1 year. So this is still dividing. City B, it is 35 divided by 7,000, that is the number or the population at risk over in the course of 2 years. So that is what we are saying, we are counting, and in epidemiology we are also dividing. And then we can also compare. Yeah. So once we count in city A, city B, and then we divide to find the number of the rate per year, which is having a certain disease, we can also again compare. So in comparative, we can say in city A, there were 232 per 10,000 per year. And then in city B, we have 250 per 1,000 per year. So this is just comparative. When you are comparing, you must have a common denominator. When you are dividing, you can have variant denominators. And when you are counting, you are only interested with the cases in a population. I hope that one is common mathematics. So definitions, we have ratio, we have proportion, we have rate. So that is what normally you will hear a lot. So when you hear a ratio, a proportion, a rate, some of them may have a denominator. So this is the numerator, maybe the number of people or the cases over the population at risk. So you may need to put some constant, which is either a percentage, you express it as a percentage, you can express it as a ratio, and so on. So that is what we are going to discuss. So when you're talking a ratio, proportion, rate, what is the denominator? So ratio, the ratio is the quotient of two numbers, and the numerator is not necessarily included in the denominator. That is when we talk about a ratio. So it allows to compare quantities of different nature. For example, we can compare girls. These are girls versus boys. So the numerator is not necessarily included in the denominator, meaning that you don't include this number out of this number to get, you don't add the numerator and denominator to get the population at risk. You just compare quantities which are of different nature. For example, the boys to girls, it is 5/2, which you can again be able to express it as a decimal, which is 5/2, which gives you 2.5 as a decimal. This one is just incorrect substitution. So that is a ratio, comparing quantities of different nature. It could be boys to girls, it could be men to women, it could be children to adults. So you are saying 5 girls per 2 boys. So a ratio examples, we can talk about the number of beds per doctor. For example, in the hospital, or you commonly hear that the ratio of nurses to patients is very small, or doctors to nurses is very small. So we can compare the beds to doctor. There are different quantities. We can be able to say 850 beds per 10 doctors. Or you can even go and simplify it further and say 85 beds per doctor. Also, another example is the number of participants per facilitator, the number of inhabitants per latrine. So all these are ratios of different qualities. So we can also have the sex ratio, where we're talking about the male-female or female-male. So examples in ratios that we have the odds ratio, the rate ratio, and the prevalence ratio. All these ones are ratios, meaning that we are comparing items of different nature. So when you hear a ratio, always remember that the things that we are comparing are of different ratio, and the numerator is not necessarily included in the denominator. So we have odds ratio, rate ratio, and prevalence ratio. So we shall talk about that later. So the other thing that we are talking about is the proportion. So what is proportion? So proportion is the quotient of two numbers, the numerator necessarily included in the denominator, and the quantities have to be of the same nature. This is a difference that you have to note. Remember, in ratio, the quantities are of different nature. But here in proportion, the items are of the same nature. So the proportion always range between 0 and 1. So percentage can also be expressed as a percentage. Yeah. So meaning that proportion can be in decimal, or it can also be expressed as a percentage. So always the proportion will range between 0 to 1 when you are talking about ratio. But when you're talking about percentages, we multiply that by 100. So for example, when you look at this, you have 2 girls over 4 girls. So it could be that these girls are the ones who passed a particular cut, and then the 4 girls are the ones, or are the total population of the girls in that school. So meaning that when we are going to the denominator, we have to include the numerator and the total in the total to be able to get the proportion. So here we are getting about 2 girls out of 4. That gives us 0.5, or when you express it as a percentage, we have 50%. So for example, AIDS cases, we're talking about 4,000 male cases and 2,000 female cases. So what is the proportion of male cases among all cases, and what is the female cases among all cases? So I'd like you to do a quick mathematics and tell me, so that what is the proportion of male cases among all cases, and what is the female cases among all cases? So I give you 2 minutes, and then I ask someone to tell us, to see that if you can be able to calculate proportion. Felix Mutinda, what is the proportion? Felix Mutinda, what is the proportion, the first section? What is the proportion of male cases among all cases? I cannot hear you, Felix. Describe social institution and their significance. So that one seems to have disappeared. Anybody who can be able to give us a response? Like how you interact with your name, how you relate with your name.
Respond of.
Yes, Philomen.
What I can say, female ratio is 2 to 3, and the other one is 1 to 3. 2 raised to 3 and 2 raised to 3. Are you getting me?
Philomen, I'm not sure I can hear you.
Hello? Hello? Are we really together?
Yes, you can go on.
You're saying?
Yes.
The male case is 2 raised to 3, 2 ratio 3. And the female case is 1 ratio 3. Am I correct?
Remember, we are talking about proportions. We are dealing with proportions, not ratios.
Okay.
So maybe I can be able to say, just for clarity, so the proportions, we have said that the quantities have to be of the same nature. So here we are talking about the proportion of male cases among all cases. We're talking about the proportion of male cases among all cases. So the cases of HIV here, we are talking about 6,000. So the proportion of male, we are going to talk about 4,000 over 6,000, like that. And then we can express it as a percentage or as a decimal. So this. 2 here, 2 here, 3. Yeah, 3 here, 1, 3 here, 33.3 times 2, that is around 66 point something percent. So that is the male cases. So the proportion of female cases, we are talking about 2,000 over 6,000 times 100. This is 1, this is 3. So that gives us a third, or 33%. So the proportion of male cases among all cases is 66%, while the proportion of female case among all cases is 33%, or 0.66 or 0.33. That is what we are talking about when you are addressing proportion. I hope now you get it. That when you're talking about proportion, the numerator is necessarily included in the denominator. So the denominator here, it is the number of HIV cases, which is 400 over 200. But when we are talking, if we are talking about the ratio of male to female, we could have said 4 to 3 or 4 to 2, like that. That means society, association. So here, for example, we have the population, we have women and men. So the proportion of men, we are talking about 6,500 divided by 3, 5, and 6, 5, which gives us 0.65 or 65%. So again, if you're talking about to male to female ratio, is where now we have 6,500 over 3,500, which gives us 1.86. So that is a ratio. And then when we're talking about the female to male ratio, we are talking about the number of female who are 3,500 over 6,500, which is 0.54. So that is the difference between when you're addressing a proportion and when you're addressing what? A ratio. Let me see if somebody there is saying something. Okay, so I hope now you have been able to get the difference clearly, that you may not be able to confuse the ratio and proportions. Then from there, that was a combination of 2 words. So we also have the rate, which is also another important thing that we have to know. So the rate is the quotient of 2 numbers, the speed of occurrence of an event over time. Yeah, that is the rate. So for example, so it is the speed of occurrence of an event over time. So the numerator is the number or the event observed over a given time. For example, we have 3 girls or 2 girls observed in 1998. So the numerator is the number of events observed over time, and the denominator, when you're talking about rates, is the population in which the event occurs, or the population at risk, and it also includes time. So for example, in 1998, we have 2 girls who are observed to have a particular disease or an event over a population of 100 girls in 1990. So you have to include time in your reporting. So that makes 2 over 100, which is equals to 0.02 per year. So that becomes what? A rate. So in a rate, time is very, very key. So rates, let's say something that may change over time or something that is observed for some time. They are called rates. So rates basically measures the speed of occurrence of an event and measures the probability to become sick by unit of time. And it can also measure the risk of disease. So time basically is included in the what? Denominator. You have to note that. So however, rate is frequently used instead of ratio or proportion. Yeah. So for example, we have rate. The mortality rate of tetanus in X country in 1995. So we have tetanus death was 17. The population in 1995 was 48 million. So the mortality rate was 0.29 per 10,000 per 10,000 per year. So basically you can be able to convert this. You take 17 over 58 or 58 million. And then you can choose to use what? Times 10,000, just to get numbers which can be read. So the rate can be expressed in any power. It could be per 100, it could be per 1,000, it could be per 10,000, yeah, it could be per 100,000. So rate, basically you are putting into account here. So that's why you'll find some reporting written 0.029 per 100,000 per year. And then we have odds. Odds is the probability that an event will happen over the probability that an event will not happen. That is the odds. Yeah. So for example, we have a match between Super Eagles and Harambee Stars for those ones who like gambling. Yeah, wale wa kuwekeza kwa sport pesa. So you'll find that Super Eagles, when it plays Harambee Stars, it will win 12 times, or the chances of it winning will be 12 times. While the chances of it losing or Harambee Stars winning will be 3 times. So the outcome here, win or a lose, is 15. So the odds ratio is the probability that an event will happen over probability of an event will not happen. So how do we get the odds of winning? The odds of we take the odds of winning, which is 12 over 3 over the total outcomes. Yeah. So you take the probability of winning is 12 out of 15 times. That will happen, that Super Eagles will win of Nigeria, over the probability that it will lose. That is the probability that it will not happen, which is 3 over 15. So in other words, the odds of winning will be 4. Yeah, like that. And then the odds of not winning will now be inverse, because the probability that it will not happen for them to win will be 3 over 15, and the probability of it now happening will be 12 over 15. So the chances of not winning now becomes the numerator, and then you find it will be 0.25. So that is the odds. So you hear that the odds of Chelsea winning is 3 points. So it is basically from this calculation that the odds is the probability that an event will happen over the probability that an event will not happen. We also have measures of disease occurrence, where we have 2 types of measure, that is prevalence and incidence. So prevalence, so unless there is any question in odds before we go for prevalence, let me hear from you. which studies the processes so basically, I can interpret that silence means that we are together. So we go further and we talk about the prevalence and the incidence. So the measure of disease occurrence. Occurrence is something appearing. We have two types of measures that you can be able to use, and that is the prevalence and incidence. So the prevalence is the measure of disease status. So we already have disease in a particular community. So we are just coming in and trying to measure to find out if or what are the disease status. So in prevalence, we can measure what is called the point prevalence and the period prevalence. So the point prevalence is at that specific time when you just encounter them. That is called the point prevalence. And then the period prevalence is where now you can be able to take the prevalence of a particular disease in a community over time. So we have the incidence, which is another measure of disease occurrence. The incidence, it assesses the frequency of disease onset. The incidence here, we are talking about new cases. When you hear incidence, always know that we are talking about new cases in a particular population. We could be talking about the case of tetanus in a particular population. Yeah. So you find that over a period of time, there are those cases that may come in, and when we measure those cases, maybe from 2000 to 2010, the new cases that will have arisen on top of what was already existing, then those new cases are referred to as what? Incidence. And when you are measuring incidence, you can be able to measure other measures called the cumulative incidence risk. We can also measure the odds. We can also measure the incidence density or incidence rate. Yeah. So that is called measure of disease occurrence, where we measure prevalence and we measure the incidence. Under prevalence, which is the measure of population disease status, we can measure the point prevalence, that is at the particular time that we meet these people, and the period prevalence, which takes place after some time. And then in incidence, which is the number or the frequency of new cases, we are measuring cumulative incidence, and we're also measuring the incidence density or incidence rate, as well as the odds. So let's go to prevalence. The prevalence, we have already said, like we have said here, is the measure of population disease status. Yeah. So here we're talking about the number of cases of disease at a specific time over the population at risk at that particular time. So proportion of a population affected by disease at a given time can also be a definition of prevalence. Remember, in proportion, the numerator is included in the numerator, in the denominator, and it is expressed as a percentage. So for example of bilharzia in Guadalupe in 1979. So the population there was 3,050. It was 3,050. The cases was cases of bilharzia was 96,200. So the prevalence becomes 27.6, because basically you are taking the cases, which is 96,200. Yeah, so the number of cases of disease here will be 96,200 over the total population, or the population at risk, which is 35 100,000. And then times 100. Yeah. So that is what we can be able to call the prevalence. So when you calculate that, you end up with 27.6%. And you say now the prevalence of bilharzia in Guadalupe is 27.6. Or you can put it as ratio, which will be 0.276. That is another way of expressing prevalence. So the prevalence is the proportion of a population that is affected by a disease at a given point in time. So the prevalence in a period of time. So for example, from +2. So when you look, when you look at it diagrammatically, these ones represent the number of cases in a population at a particular time, which was like that. So you just take the total number of the cases divided by the total number of population. So for example, in a survey of patients in OPD clinic, 60 out of 30 or out of 300 interview patients reported use of bed nets in the last 2 months before interview. So the period prevalence for bed nets used over 2 months is calculated as you identify the numerator, which is the bed set users, which is 60. And then you identify the denominator, who are the number who are interviewed, which is 300. So you calculate the numerator over the denominator, which gives you, if you express it as a percentage, you multiply by 100, giving you 20%. So that is still prevalence. So you can be able to calculate that occurrence in a particular time. Yeah. So what are the uses of prevalence data? They can be used for assessing healthcare needs, because when you want to look at a particular disease, maybe let's say you want to start a program in a community. So it is important for you to know the prevalence, so that when you put that activity within that area, let's say you want to start family planning, you ought to know what is the number of women who will require family planning services, so that you can be able to get profit. So it helps in assessing healthcare needs. It also helps in planning health services, like for the example which I've already told you. And then also, it measures the occurrence of conditions with graduate onset. And then it can also be able to allow us to study chronic diseases. For example, we can say the prevalence of people with diabetes, yeah, in a particular community is 20%. So the chronic diseases, we can use prevalence data. When you are planning for health, prevalence data. When you are assessing healthcare needs, prevalence data. Because most of you are going to end up as nursing services in charge at different areas. So in those areas, you may be required to present this data so as it informs the health management team in order to plan for services. So you will need to give them the prevalence data. And then you have the incidence, whereas prevalence and frequency of existing cases in the population, the incidence, we are saying, is the frequency of new what? Cases. That is what I was telling you, my friends, ladies and gentlemen. The new cases that occurs in a population over a specific period of time. And there are 3 different ways in which you can be able to measure incidence. We can be able to use cumulative incidence risk, or the incidence rate density, and the odds. So for example, this is a diagrammatic representation of incidence. When you look at this, You have the prevalence cases. These are the cases. It could be the malaria. It's actually, when you look at this, it's like a basin. We have water and we have tap that is getting new cases. So whatever is now being added to the already known cases is what is referred to as the incidence. And whatever is already known is what? The prevalent cases. And then we have those ones who are exiting, either in form of death, emigration, and recovery. So this is the duration. Remember, in prevalence, we said we can have point prevalence and we can have period prevalence. So the point is the one which you can be able to see at this particular time, and the period we take a particular duration. So when you look at this, yeah, we have, this is still another presentation where we have a population, and from this population it could be increased either by births, people who are migrating inside the population. It could be those people who have recovered from illness. So whatever is living from that population and adding into the already number of cases is what we call the incidence rate. So from the population, again, from the larger population, we can be able to get some incidences who now join the prevalence, who still are part of the population. And then they can be able to exit. Of course, the prevalence can be affected by recoveries, and also it can be affected by emigration and non-measurable cases and death. So you may find it is common for you to find the prevalence fluctuating because of what I have been able to highlight. That is recoveries, immigration, and death. So let us start with the cumulative incidence. Cumulative incidence is the number of new cases. Remember, it is incidence cases during a period over the population at risk during that period. For example, we have bilharzia in Budalangi in 1979. So the population is 35,000. The new cases is 1250. So the cumulative incidence per year, yeah, you will take the new cases, which is 1250, over, that is 1250 over 3500 times, you can be able to put it times 100 if you want to express it as a percentage, yeah, times 100. Remember, you also have a year. The year was 1979. So therefore, the cumulative incidence is 3.6. You can put it per 1,000, per 10,000, per year. Or you calculate it as a percentage to give you the frequency. Not, yeah, to give you the prevalence. So what is the total number of cases in 1979? That is the first question, which is 1250. So this is just to depict the durations, how duration can be able to affect prevalence. Where when we talk about a duration over a period of time, that is period prevalence, you find there are other cases which can start. Some cases may begin in mid-July, and before July ends, it disappears. Some cases may start in July and mid-July. Some cases may begin mid-July and go up to August. So basically the issue of time will again be able to affect prevalence and incidence of a disease. That is just the grammatic impression. So when you look at this, some disease may start at early July and then go and then terminate in August. So it's the effect of time. So when you are measuring prevalence, your timing and also incidence is very, very key. You may measure when there are no diseases, where the diseases are ending. So you can be able to give feedback which may not be necessarily true. So time affects the prevalence and incidence. So we talk about odds, similar to cumulative incidence, but rather than use the number of disease-free people at the beginning of the period, we use the number of disease-free people at the end of a specified time. So the odds of a disease is equal to number of new cases during a period of a number of people still disease-free at the end of the period. So basically, we are comparing the new cases versus those people who are free. They have never been affected. That becomes the odds, meaning is the occurrence over the chances, the probability of occurrence over the probability of not occurrence. So here also again we have incidence rates. This one you may not need to know it much, but the incidence rate is the number of new cases of a disease during a period over the total person minus time at risk in the period of observation. So this one is just good to know at this point. Also called force of morbidity or an incidence density. So the denominator here is the measure of time and the sum of each individual free who are at risk from the disease. So we also have this one is just, that one I don't want to bother you much to be able to understand that at particular time. So, but you can be able in your free time to go and review it. So that marks the end of the lesson. So basically in this second part of the second session, we have been able to cover, we have been able to define and use ratios, where we have said ratios, we are having population which are not same. So maybe you can say the ratio of male to female. So you just take the denominator, the numerator is not included in the denominator. And then in proportion, we have said now the numerator is also included in the denominator. Yeah, because the population here are people who have same or similar characteristics. It could be you are measuring the number of HIV in males and females, and the proportion you have said it expressed as a percentage or a ratio. Yeah. So, and then the rate, on the other hand, we have been able to bring in the aspect of time to it. And then the odds, we have been able to talk about odds as the probability of occurrence of an event over the probability of not occurring. And then we went further and we talked about the prevalence and incidence. From there, we have talked about the point, prevalence, and also the period prevalence. And then incidence, we have talked about cumulative, the incidence rate, and the odds, incidence ratios. So you need to master those formulas and also try as much as possible to put it into practice. So maybe if you have a question, you can be able to say. Any addition or any contribution? Any concern? Okay. So I will be able to post these lectures, sorry, in the YouTube channel, in my YouTube channel. So should you want to go over and listen and get maybe more points which you did not get during the session, you are going to get it there. And also, please, as you do it, you can also be able to subscribe to that channel for you to be able to get more lectures and also notifications of lectures which I post in that group. So thank you very much for logging in, and let us meet, I think, on Wednesday, where we shall start on a different thing. Thank you very much. Nice time. I know almost most of us have ever watched